Chords. The definition of a chord is a chord of a circle is a straight line segment whose endpoints both lie on the circle. So for a quick sketch, we have a circle and a chord could be anywhere across the circle. And there you can see my endpoints lie on the circle. Let's look at some relationships that are made by chords. In example 1, it says y is rs congruent to ut. So rs is this chord and ut is the other highlighted chord. Let's break down what we know about this triangle. We have these two angles are vertical angles, therefore they are congruent. Since Q is the center of the circle, the distance between Q and each point on the circle is a radius. Therefore, we have 4 congruent radii. I'll identify those with a green hash mark. Now if we look at just one of the formed triangles, so let's say this one on the left-hand side, we have a side, an angle, and another side. So we now look at the right-handed triangle, and we have a side, an angle, and another side. Therefore, the left triangle and the right triangle are congruent. So therefore, in my therefore sign are these 3 dots. RS, the chord of RS is congruent to the chord of UT by CPCTC. And remember that stands for congruent parts of congruent triangles are congruent. That fun acronym. Why don't you try this one? So take a look at the diagram on the right, and the question is asking why angle BAC, so BAC, and angle DAE are congruent. So pause, and then I will show the answer. The 2 chords are congruent, that's given in the question. Then we have the 4 radii that are congruent, so therefore the triangles are congruent by SSS, and the angles are congruent by CPCTC. Congruent chords. Chords in congruent circles or the same circles have congruent central angles. So what that means is if you want to look at the left-hand circle and the right-hand circle, if the circles are the same, if the circles are congruent, and FE is congruent to CB, then that means that the angle of D and A are also congruent. Congruent arcs in congruent circles or the same circle have congruent chords. Therefore, if we're told that arc FE is congruent to CB, then that means that the chords also have to be the same length. So in example 2, we're given 2 different circles, and we're asked what the measure of arc FG is. So FG is this arc. If we have 2 congruent circles, and you can see that the chords are congruent by this double hash mark, then that means that FG is going to be 80 to match the arc of the right-handed circle. Now you guys can try this one on your own, so pause, answer the question, and then I will put the answer up so you can compare. And here are the answers. Bisecting chords. If a chord is perpendicular to the diameter of the circle, then the diameter bisects the chord. So here is the diameter, that's the hash line, and then here is the chord. And notice that if the diameter is bisecting the chord is congruent from PD to PF. Example 3. So we have a circle, we have a diameter, we have a chord. So that means that we have a diameter bisecting a chord, meaning that these two lengths are identical and congruent. So that means that we can set our two expressions equal to each other and solve for x. So 12x is equal to 13x minus 4. We'll collect like terms. So I'm going to bring the negative 4 to the left-hand side by adding 4. And I'll subtract 12x from each side to bring the x to the right-hand side. And I do it this way because I like to keep my x's positive. So by doing this, I have 13x minus 12x on the right-hand side, which gives me positive 1x, and then positive 4 on the left-hand side. So x is equal to 4. Find the measure of arc TF. So go ahead and pause and try and do this on your own. All right, let's see how you did. So we are trying to find the measure of this arc. We know that it's congruent to 37x, so that means we need to find 37x. And to find 37x, we need to find x first. We have a diameter that is bisecting a chord, and so therefore we have the two segments of the chord that are congruent. So we'll start with setting 13 equal to 3x plus 7. We'll subtract 7 from both sides. So we get 3x is equal to 6 and x is equal to 2. To find arc FC, we will plug in x as 2. So we get 74. So therefore, arc TF is also equal to 74. Equidistant chords. Chords that are equidistant from the center of the circle or centers of congruent circles, if we have more than one circle in our question, are congruent. So if we're looking at the two circles on the bottom left, chords that are equal distance from the center, so if we are looking at the red lines, we see that they're equal distance by the hash mark, identifying that they are congruent. Therefore, the chord of BC is congruent to FG. So here and here. Or if they're in the same circle, so we have congruency with the distance from the center. So therefore, the chords LK and NO are also congruent. So in example 4, we have a very busy looking diagram. We have a diameter that is bisecting two chords. So if it bisects two chords, then we know that QU is congruent to UR, and we know that SV is congruent to VT. Since we know that that is congruent, and we're told that QR and ST are 16, then we can identify that each segment here is a length of 8. We also have our equal distance from the center. So that means those two lines are congruent. And how we know that they are congruent is the fact that the chords that they're attached to are congruent. So because we know that QR chord is congruent to ST, then that means our expressions of 2x and 5x minus 9 have to be equidistant from C. So let's set the two expressions equal to each other. And solve for x. I bring my x's to the right-hand side, my whole numbers to the left-hand side, so we get x is equal to 3. We'll use this x to plug and find the distance from the center to the chord. So this is now going to equal 6. So how is this going to be helpful to find the radius? Well, we have a radius. We'll use this one right here. If we look at this triangle, we can use the Pythagorean theorem to solve for the radius. So I'm going to pop this triangle out. So we have R, C, and U, 6, 8, and this is what we're going to solve for. So we use the Pythagorean theorem. So 36 plus 64 is equal to R squared. So 100 is equal to R squared, so therefore R is equal to 10. Now it's your turn to try. So pause, try this question, and then check your answer. So similar to the last question, if we know that the chord JK is congruent to LM, and they're both 24 units, they are being bisected by the diameter SR. So therefore we know that JP, PK, LQ, and QM are all congruent, and they are length 12. Since the chords are congruent, we know that they are equidistant from the center. Therefore, 3x is equal to 7x minus 12. We solve for x and get x is equal to 3. Then we use the information to plug 3 back into the expression. We get that distance of the chord from the center to be equal to 9. And then we've created a right angle triangle where the hypotenuse is the radius of the circle.